Now, hello class, and thank you for watching. On topic 3.4 and 3.5, sinusoidal graphs and functions, your learning objective here is to construct representations of the sine and cosine function using the unit circle and identify the key characteristics of these two functions. We'll begin by first reviewing the graphing of the sine function. Now, because on the unit circle, the sine function are the y coordinates on these angles, we can identify what the sine of pi over 6 is going to equal to, pi over 3, pi over 2, and so on by looking at that value there. Now, if you recall again by the memorization trick, I know that the sine of 0, I don't have that one right here, but the sine of 0 is equal to 0. So my sine function is going to have a coordinate at 0, 0 right here. Okay. On the graph that we have right here below, the x-axis is the angle measurements. That's this value right here. And the y-axis is the value of my sine at those angles on this coordinate system. So we're just simply transferring the data from the unit circle to a rectangular coordinate plane. So if I look at the first example, the first coordinate at pi over 6. Well, let me start at pi over 3 because I know I have this one memorized. At pi over 3, since the denominator is 3, I know that sine will be radical 3 over 3. So radical 3 over 2, radical 3 over 2. Which means that at any time that sine has a denominator, the angle of sine has a denominator 6 or a multiple of pi over 6, I know that those are going to equal to 1/2. So this will be radical 3 over 2. This would be 1/2. 1/2. Radical 3 over 2. Radical 3 over 2 and 1/2. Now on the 90-degree angle, since we're on the x-axis, the y coordinate there is going to be the value of 1. So this would be 1 and this one right here would be 1. And then at the pi angles, and that's 2 pi, since we're on the x-axis, the y coordinate on the x-axis is 0. So we're going to be 0 there and 0 there. And recall again, in terms of positioning, 2 pi, a complete 360 degrees, is the same thing as 0 radians, 0 degrees. So those are going to have the exact same y values. So if I transfer those data points onto my coordinate grid, I start at 0 and I end on the x-axis at 0, I'm going to have the following coordinates. So pi over 6 will have a y coordinate of 1/2. Pi over 3 will have a y coordinate of radical 3 over 2, which is around 1.78 or 1.8, 1.7. And then it again cycles. So we go up, reach our maximum at 1, and then go downwards, decrease. And then we go to below the x-axis, because at these values, which I forgot to change the signs here. Let's go back and write in the sign here. Since these numbers are going to be in quadrant 3 and in quadrant 4, that means that the y values in those quadrants are going to be negative. So this should be negative, 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 and of course 0 is negative. So let's plot those points. And the graph of the sine function looks like this. Now tomorrow we'll be focusing on how to translate this along with the cosine function, and we'll discuss again those type of representations tomorrow. Now, what are the properties of these sine functions? Well, the properties of the sine functions, the key properties of sine functions are the amplitude, the midline, the period, and the frequency. Let's first discuss how we get the midline of a sine function. To get the midline of a sine function, we simply have to, as you see right here, get the is half the distance, halfway between the maximum and minimum value. So in other words, the midpoint, but it's just a line. So from geometry, you should be familiar to get the midpoint. All we have to do is get the max point and the min point, add those values together, and divide it by 2. Well, the same thing we're going to do here. the midpoint of this value of this function is 0 because the highest point is 1 and the lowest point is -1. So -1 plus a +1 equals to 0, and 0 divided by 2 equals 0. So that's how you calculate the midline. Now, when you have the midline, you can then determine what the amplitude of the function is. The amplitude is the distance from the midline to the maximum, or from the midline to the minimum. So that's this distance right here. This right here is the amplitude. And the way we can figure out what the amplitude is we can simply count from the midline going up or down. As you see right here, this would be half and then another half. So that would be a whole unit of 1. So 1 unit. So our amplitude is equal to 1 because of that. Or to go from the midline down, I know we see that's 2 squares, but each square is equivalent to half of a value. So 1/2 plus another half, that's equal to 1 whole unit. So that is going to be our amplitude. Now, mathematically, you can convert and identify what the amplitude is by simply figuring out the difference between the max and the minimum value. So figure out again what the overall length of this entire value is. So if you could figure out how long this value is, which is calculated by subtracting them this time, and then dividing that length by 2, that's going to tell you the distance from the center to the bottom or the center to the top. Okay, so mathematically, that's how you can figure it out without having to actually count from the center down or the center up. Now, the period of a sine function, remember, is the length of one cycle. And since our sine function starts at 0 and ends on 0 on the x-axis, again, basically we start on the midline and we end on the midline, having one maximum and one minimum, we can calculate the period again by figuring out the length of that value. So right here we have a length of 2 pi. That is our period, 2 pi, because from 0 to 2 pi, that is the length of that. And again, anytime we're looking for the length of anything, we can always calculate what the period is by simply getting the maximum on the axis. I'll put a little x in parentheses right here, and subtracting it from the minimum value of the axis when we see one cycle. And for a sine function, like I mentioned earlier, our sine function always starts on the midline, has a maximum first, and then has a minimum second before the cycle finishes. So we can figure out what the distance is from here to here by subtracting the maximum x value by the minimum x value. We're going to get our period, which in this case is just 2, because 2 pi minus 0 is 2. And finally, the frequency. The frequency is simply the reciprocal of our period. So whatever our period is going to be, our frequency is simply going to be, in this situation, the reciprocal. So if our period is 2 pi, our frequency simply would be 1 over 2 pi. Simply flipping that number upside down from 2 pi over 1 to 1 pi over 2. Now, let me discuss what the frequency states and what that means. The frequency of having 1 over 2 pi means that we're simply going to see one cycle in a length of 2 pi units. So every 2 pi units, so from, let's say, pi to 3 pi, we should see one cycle. So in other words, one minimum and one maximum. Okay, that's what the word frequency identifies on our graph for sine. Let's now look at the sine function, the cosine function, the cosine function. Well, the cosine function on the unit circle are the values of the x-coordinate at those respective angles. So at the cosine of pi over 6, the x-coordinate there is radical 3 over 2. So radical 3 over 2. At pi over 3, that x value is 1/2. And at pi over 2, that x value is equal to 0. So with cosine functions, you'll notice that these coordinates, the x-coordinates, are decreasing in value because since the unit circle goes in this direction, since our angles are rotating in a positive direction right there, we're getting closer again to the y value. To the y-axis. So these points are simply getting closer to the y-axis, and then on this coordinate, they move away from the y-axis, which makes that the x values are become more negative, moving further away. So when we go on the second quadrant, this is simply going to rotate and flip itself around across the y-axis. So we'll end up with negative 1/2, negative radical 3 over 2, and negative 1. Since at 0, the x value is equal to 1, over here we're going to stop at negative 1. Now, continuing in the bottom quadrant, well, in the bottom quadrant, since we're looking at the x values, to the left of the y-axis, those values are going to be negative. So these values right here are all going to be negative, and we're going to have negative radical 3 over 2, negative 1/2, and negative 0, which is just 0. And then when we move to the next quadrant, quadrant 3, these are going to be positive. Since again, we're looking at the x values. So the cosine of radical of 5 pi over 3, that is equal to 1/2. 11 pi over 6 is radical 3 over 2. And at 2 pi, the x value is equal to 1. And just like with sine, you're going to notice again that you have the exact same values. At everything that has a denominator 6, your ratio, your ratio is going to be radical 3 over 2. Radical 3 over 2. Okay? Like I said, the best way I have these memorized is I just simply memorize sine. I know that at sine, when the denominator is 6, we're going to end up with 1/2. So cosine would have to be the other one, radical 3 over 2. And for sine, when our denominator of our angle is 3, this would have to be radical 3 over 2. So with cosine, it's just the other value, 1/2, okay? And then to determine again when cosine is going to be positive and negative, well, because it's the x values, it's going to be positive in quadrant 1 and in quadrant 4. So only at the very beginning and at the very end. Everything else in between is going to be negative, as you see right there. Sorry, wrong one. This one right here, right there. Okay, they're going to be negative. So if I plot this, since I'm going to start at radical 3 over 2, at 0, we're starting at 1, so I'm going to start my first point right here at 1. At pi over 6, that's going to be radical 3 over 2, so that's a little bit, like I said, that's around 1.8, 1.7. Pi over 3, that's going to be 1/2, and at pi over 2, that becomes 0. Then I'm going to be in quadrant 2, which is going to be on negative value, so our graph is going to be below the x-axis. Pi over 3, that's going to be negative 1/2. 5 pi over 6 is negative radical 3 over 2, and at pi, it's negative 1. Then in quadrant 4, we're going to start moving upwards. As you see right here, the graph is going to oscillate moving upwards. So 7 pi over 6, that's negative radical 3 over 2. 4 pi over 3 is negative 1/2, and 3 pi over 2 is back at 0. And then at 5 pi over 3, we are going to be at 1/2. 11 pi over 6 is radical 3 over 2, and at positive 1 when we get to 2 pi. So connecting these points, our sine function looks like this. And this is one complete cycle of our sine function. So a complete cycle of our sine function goes from a maximum to a maximum. And it only has, well, it still has two concavities, okay? It's concaving down right here, and then concaves up right there. So whenever the graph is below the x-axis, it's going to be concaving down, or as you see, below the midline. It's concaving upwards, and above the midline is going to be concaving downwards. So let's look at those characteristics. And just like with the sine function, it has the exact same characteristics. The amplitude here is going to be the distance again from, midline. Let's start with midline. The midline of this is going to be the distance between, half the distance between the maximum and minimum value. So if I use the midpoint formula and get the lowest point, add it with the highest point and divide that by 2, in this example, I'm going to see that the midline is at 0 yet again, because negative 1 plus positive 1 equal 0, and half of 0 is still 0. The amplitude is simply going to be half the distance between the lowest point and the highest point. So to figure out distance between 2 points, I simply subtract the two values. So I usually start with the maximum and subtract the lowest one, but you could do it the other way. Just remember it's going to be positive. So I do 1 minus negative 1, that's equal to 2, and 2 divided by 2 equals 1. So that is your amplitude, which can also be calculated if you look at the graph. That's simply the distance from the highest point to the lowest point right there. Okay? I'm sorry, from the midline, my bad. From the midline to the lowest point, or from the midline to the highest point. That is also a length of 1. The period is the length of, again, of one cycle. And in this situation here, our period again starts at 0 and is going to finish at 2 pi. So that would be our period. We could also figure out the period by simply getting 1 point and looking at where the cycle repeats itself. Like if I look at a minimum and see where the next minimum is, figure out the distance between those two things, just the same way I figure out any distance by subtracting the larger value by the smaller value. The frequency is simply the reciprocal of our period. So right here, our frequency would be 1 over 2 pi. Let's now discuss the term a sinusoidal function. A sinusoidal function is a function that involves additive and multiplicative transformations of the function sine of theta. So if I do any type of horizontal transformation, any vertical transformation, that is referred to as a sinusoidal function. Now, both sine and cosine are considered to be sinusoidal functions. Even though by name this is cosine, if I transform the cosine, it is also referred to as sinusoidal function, because cosine of an angle theta is the same thing as simply doing a horizontal shift of sine by pi over 2. So simply shifting this graph to the to the left by pi over 2 units is going to create the exact same function. As you see right here, look. Okay, here's my sine function. I'm going to trace it as best as possible right there, okay? And this is what the function will look like over here. If I shift it over, right, look where pi over 2 is. So if I shift that over, pi over 2 units, I shift that over, okay, to there, I create the cosine function that has been shifted to the right by this many units, okay, by that value right there, okay. So that's why cosine functions are considered to be sinusoidal functions as well. Let's now look at some sinusoidal functions and identify the key characteristics to these functions. In example 1, the two periods of the sinusoidal function f are shown in the figure above. We want to find, like I said, the period, the frequency, amplitude, and midline of the graph. I recommend finding the midline of the graph, because the way to figure out the midline, that's always the easiest, in my opinion, because all we have to do is simply find the middle. If I focus on where the highest point on the graph is and figure out where the lowest point on the graph is in terms of y, okay, so the highest y value is 6, the lowest y value is 0, I can find the middle by finding the middle of that. And the way we find middle is by using the midpoint formula. So I will add 6 plus 0, so 6 plus 0, and divide it by 2. Well, 6 plus 0 is 6, divided by 2 is 3. So our midline here is going to be this blue line, which is at y equals to 3. Which again, you could just also just see that, and I automatically identify that the middle would be that value there. But again, mathematically, that's how you do that. So our midline is going to be the equation y equals to 3. And the reason I like finding that one, because all I have to do in order to figure out the amplitude, now that I have that, The amplitude is simply the distance from the midline to the highest point or to the lowest point. So I can use either this point right there and go to the highest. Since I'm at 3, to go to 3, that's 3 units in length. Or I can figure out the distance from the lowest point to the midline. Since again my midline is at 3, to go all the way down to 0, I would have to go a distance of 3. So our amplitude equals 3. I would then find the period. The period is the distance of one complete cycle. And I recommend, because this is a sinusoidal function, again, a sine function that has been shifted, all right, or that has been shifted horizontally, I would recommend looking at the lowest points and going from min to min or max to max. In this situation, it's probably not the ideal thing to do because the max is at this value and I don't know what this x value is. And to count what the distance from here to here, that's going to be hard as well because I don't know what that mid value is. So I'm going to have to, again, see that there's 2 cycles, know the fact that there's 2 cycles, and see where the graph reads itself. So if I was to start here at 0 at this point right there, 1 cycle of this function here, let me do it in yellow so it could stand out, will look like this, okay? So this would be one example of one complete cycle of this sinusoidal function. And if I continue it, this would be my second cycle right there. So all I have to do is figure out the length of one of these cycles. I would recommend starting the one that's at 0 right here to here, because in order to figure out the distance between 2 points, that again, all we do is subtract. And because we're going to subtract by 0, then it's just going to be that. It's going to be pi minus 0, which is going to be pi. So our period here, let me do it in purple. Our period here would be the distance from this point to that point. So from 0 to pi. And again, and the reason I did that, because when I subtract by 0, nothing happens. So we just end up with pi. So our period equals pi. And the last thing I would find would be the frequency, because our frequency is simply the reciprocal to our period. So 1 over pi. What the frequency is basically stating is just how many cycles I can fit, okay? So the length of one cycle, see right here, one cycle has a length of pi units. So you see, so when I go and make one cycle, this length right there is pi. That's what frequency does, is referring to. So if I go another pi unit, so from pi to 2 pi, I will find one cycle in there. Okay, which again correlates again to period, just in a different perspective. Let's look at the second example. Several points of the sinusoidal function g of theta are shown in the figure above. Again, we want to find the same things as before. I again would start with the midline, and I would want to find where the midline to the sinusoidal function is. So here, to get the middle, I just see what the lowest value is. So let me do that in red. The lowest value, highlighter, is -1. The highest y value is +3. So to calculate the midline, we're simply going to get the midpoint. So we're going to get -1 plus 3 and divided by 2. -1 plus 3, that's equal to +2. +2 divided by +2 equals to 1. So our middle is at 1. Now to double check, simply count from the midline to the lowest point, which is 1 to 2 units, or and to the highest point, and it should be the same value, 2 units. So that's right, 2 units right there, okay? Which correlates again perfectly to the amplitude. So we know that our midline is the equation y equals 1, and our amplitude here is 2. From 1 to 3, that's 2. From 1 to -1, that's a distance of 2. Now to figure out the period here, because we have so many cycles here, we are going to just figure out the distance from one max to one other max, or from one min to another min. I'm going to do the maxes because the maxes are labeled. I know that this max here is located at pi over 3, and the next max is at pi. So from one max to another max, that would create a one cycle of a cosine function, which again would be the sinusoidal function that would give me the period of this entire function itself. So to figure out the distance, again, all we do is simply subtract. So we're going to get pi let me highlight it here. So we want to get the distance from here to here. That is going to be our period. So we're going to get the value of pi and subtract pi over 2, which is the same thing as thinking about this as 1 minus 1/2 pi's. And 1 minus 1/2, you should be familiar with that. That's just 1/2. You have $1, you take away 50 cents, you end up with 50 cents. So pi over 2 is our period. Or half of a pi. And our frequency is the reciprocal of that, so 2 over pi. So what that means is that we should see 2 cycles from 0 to 2 pi, or in the length of pi. So if I go from 0 to pi, I should see 1 cycle and then a second cycle, which is true. Look at this. So we have 1 cycle. Let me get yellow. So 1 cycle is right here. And then this is a second cycle right there. Okay. So you see that. And then when I go 2 pi, I should see the exact same thing, and I do. 1 cycle, and here's the second cycle. Let's now look at some word problems. Description of this. All right, so just to give us a sketch of this, we're going to draw a y-axis, we're going to draw a x-axis, and we'll just draw a sine function like this. Okay, it doesn't have to start exactly on the y. So let me draw this again. All right, and we're going to just simply do this on purpose. Okay, now it says that we pi and 8. So when x is equal to pi, the highest value is going to be 8. Now the minimum occurs at 3 pi. So when x is equal to 3 pi, this is going to have a minimum of -2. And we want to find again the exact same things as before. Well, like before, I want to figure out where the middle is, the midline. So to find the midline, since I know what the minimum and maximum is, I'm simply going to find the middle of that by using the midpoint formula. So 8 plus -2 divided by 2, that equals to a total of 3. So our midline is at 3. So to figure out the amplitude from this point on, okay, our amp, since I really don't have a picture, I don't know what this value is, I could just simply figure out the difference from the maximum to the minimum. So, or figure out again what the half the distance. There's several ways. I could figure out half the distance from the lowest to lowest point, or I can, since I know where the midline is, simply figure out what the distance is from the middle to the top or the middle to the bottom. Easiest since I already know what the midline is to start with the middle and figure out what the middle is to the top. So the way to figure out distance is to get the larger value of 8 and subtract it by the midline, which is going to be 3, and that's going to be a total of 5. So that equals to 5. Our amplitude is 5. And that makes sense. If my middle is 3, 3 plus 5 brings me to a max of 8, and 3 minus 5 brings me to a minimum of -2. Now the next part is going to be the difficult part here, okay? Is trying to figure out what the period is, because this, again, the one cycle of a sine function will look like this, okay? But I don't know where the starting point is, and I don't know where the ending point is. I do know that the max is at pi and the min is at 3 pi. So if I do one more cycle, let me do my next cycle in red. And again, it's not drawn to scale. Since this distance right here is 2 pi, from pi to 3 pi, that's a distance of 2 pi. That means the same thing right here. From here to here, that has to be another 2 pi of equal length, okay? So from one max to a min, that horizontal distance is 2 pi. That means that from this min to this max, that has to be the exact same distance. So this right here would have to be 5 pi. Okay? So our period here would be, if I look at the distance from the maximum to this maximum, our period would give us a length of 5 pi minus 1 pi. That is 4 pi. So our period equals 4 pi. And if I think about how it compares again to this distance here, let me do it in this color right here in gray. If I think about the distance from here to here, which was just simply 2 pi, 2 pi plus another 2 pi equaled 4 pi. So if I know what the distance is from one max to one min, then the period would simply be twice that distance. Because from one max to one min, we're creating half of a cycle of a cosine function. This is half of a cycle of a cosine function. So the other half of the cosine function would be, again, twice as long. So that means that our period is 4 pi, and our frequency is 1 over 4 pi. Let's look at another example. In the next example, the sinusoidal function s has a maximum at the point of 315. The first minimum after reaching this maximum occurs at the point 83. Let's find again the same characteristics of this sinusoidal function. So just for a point of reference, let's draw an x and y axis. And let's draw a sine function. So we'll draw a sine function. Okay. And let's figure out what these things are. So maximum occurs at 315. So at 3, and this value is 15. And then the first minimum after this max occurs at 8, 3. So at x equals 8 and the y value equals 3. So to figure out our our midline, I'm going to start first with the midline. I'm simply going to figure out the middle between these two, between the max and the min. So 15 plus 3 divided by 2, that's going to be 17 divided by 18, 18 divided by 2, which equals to 9. So our midline is 9. So y equals 9. So to figure out the amplitude, we just simply need to figure out the distance from here to there. And to figure out distance, subtract. 15 minus 9, that's equal to 6. Amplitude is 6. Now our period, the same behavior as before. Since we only have this, and I'm going to do it the same way. So to figure out our period, this again is not a complete cycle. If I only look at this portion right there's not a complete cycle. A complete cycle of a cosine function will go from max to max. So if this distance from 3 to, since the distance from 3 to 8 is 5, 8 minus 3 equals to 5. That would mean that the distance from this minimum value at 8 to the next maximum value, which would be right here, that distance also has to be 5. So from here to here, that also has to be a distance of 5. And 8 plus 5, that equals to a total of 13. So to figure out the period here, I will go from 3 to 13, which, look at that. That is a distance of 10. 13 minus 3 equals 10. So our period is 10 units. Now you'll notice again, you'll notice that in this example, that the distance from here to here, which is 5, is just half the distance of the entire period. So make that connection, that from one minimum to the next maximum, or vice versa, the minimum to the next maximum, whatever that distance is, the length of the period is going to equal to twice that number every single time. So 10. And that brings us to our last thing that we need to know is the frequency. Move this out of the way. Our frequency is 1 over 10, which means that we will have one cycle every 10 units along the x-axis. So from 3 to 13, you see we have one cycle of the cosine function, and from 13 to 23, we'll have another cycle of the cosine function. Okay. Now for this next example, example 5, the sinusoidal function k of theta has a minimum at the point of pi over 2, -1, and the first maximum after reaching this minimum occurs at the point pi 7. I'm sorry, not pi over 7, pi 7. Find the period, frequency, amplitude, and midline of the graph. So let's draw a x and y axis, and let's draw a sine function. Now this one says that the minimum is occurring first, and then the first maximum reaches afterwards. So let me draw this sine function in reverse. So let's flip this. Okay, so let's fix this. So instead of going up, we're going to go down to have a minimum first, and then up to have a maximum second. So just the same thing as the previous, just like the previous examples, but now we're just simply going to flip it. Flip where it starts off. So our minimum is occurring at pi over 2, and that minimum value is -1. And our maximum occurs at pi, and that has a y value of 7. So our midline right here would be the middle between those two values, which from -7 plus -1 divided by 2 is equal to 3. So our midline is 3. And our amplitude would be the distance from this middle value of 3 to the maximum, or I could go downward to the minimum, which is going to be 4. 7 minus 3 equals 4. So that's our amplitude. Now, same thing as before, okay? So here, let's figure out what the distance is from this point to that point right there, okay? So the distance from here to there. Well, pi minus pi over 2, that's the same thing as 1 minus 1/2 pi's, which is just 1/2 pi. So since this distance is half of a pi, then that means that the period will be twice as big. So our period would add another half pi, which will give us 1 complete pi. And our frequency is simply the reciprocal of that, which is 1 over pi. Now, to the first problem that we talked about on the free response question for the AP test, number 3. So here we have again the same scenario as before. We have this clock, okay? The figure shows a large clock mounted to a vertical wall at t is equal to 0 minutes. The minute hand is pointed directly up at the 12 and is 130 feet from the floor. So the distance from here, okay, to the floor, to there, this distance right there is 130. When the minute hand is pointing directly to the directly down to the 6, the distance to the floor is 117 feet. So from the bottom of the clock, in other words, to the floor, that's 117 feet. Now the clock is now working properly, and the minute hand rotates 5 times in 2 minutes. As the minute hand moves, the distance between the endpoint and the minute hand and the floor periodically decreases. So let's talk about this information that we have here. This again is not the period of our graph, okay? What this is saying, this is right here is our frequency, and that we're gonna, well, not even our frequency, that we're rotating 5 times every 2 minutes. So no, that is our frequency, that in 2 minutes we should see again this cycle. Again, we should see 2 cycles of this from 0 to 2, 2 to 4, 4 to 6, and so on, okay? We should see this entire cycle. So if this starts at 0, this right here, our 1 cycle, our 2nd cycle, this distance right here would be at 2, okay? 2 minutes. So, but we would see 5 of them, not 2 of them. We would see 5 of these. So we need to do 5 of these before we get to 2 minutes. So that's our frequency. So to figure out the period, we're simply going to get the reciprocal of this. And our period is going to be 2 over 5, which is 2 over 5 seconds. So the length of 1 cycle, so from here to here, is going to be 2 over 5 minutes, not seconds, minutes. Now, since the hour clock again is going to be pointing to 12 and then to 3, then to 4 and to 9, okay, we need to figure out what these times are going to be by dividing simply this value by 4. So we're going to get our increment of our time by getting 2 over 5 and dividing it by 4, which is the same thing as multiplying by 1 over 4. So this is 2 over 10. Now we're not going to reduce that fraction right now. We're going to keep it like that, okay? So we're going to increase this from in increments of 2 over 10. Now we are starting at 0 and the clock is at its highest point at 0. So our 0 value is going to be right here, okay? So to figure out, I didn't write in the values. We start with the y values first, okay? Our strategy is always to start with the y values. So the maximum is going to be 130. Our minimum is going to be 117. And to figure out what the middle is, that's going to be our midline. We simply need to get the middle between these two things. So let's do that work over here. So 130 plus 117. That's 742, and divide that by 2. That's 1, 2, and 3, which is 6 minus 1. Carry over a decimal point. So 123.5. So our middle value here is 123.5. That's the midline. Okay, there. Now that I have this, going back to what I discussed earlier, our starting point is at 0. At 0, the minute hand is directly at 12, and it's 130 feet from the floor. So that's going to be the highest that the minute hand is going to be from the floor, the furthest away. So we're going to start right here at F. And we're going to start at 0. And since we're increasing again in intervals of 2 over 10, this right here would be 2 over 10, 4 over 10, 6 over 10, and 8 over 10. No, hold on. 20. Why am I saying 10? 20. 4 times 2, 5 times 4 is 20. I thought that was off, okay? Sorry about that. I caught my mistake late, but I caught it. So 2 over 20, 4 over 20, 6 over 20, and then 8 over 20. Okay? So the coordinates of these things are the following. F has a coordinate of 0, 130. G has the coordinate of 1 over 10, 123.5. J has the following coordinate, 4 over 20. That simplifies to 1 over 5. And the y value is 117. K is 3 over 10 at 123.5. And then point P has the coordinate of 8 over 20, which if I divide both of those by 4 is 2 over 5 and 130. Okay, so those are the coordinates for that. And now let's figure out the period, frequency, amplitude, and midline. Well, we already did all that work. We know that our period is going to be 2 over 5. Okay, the frequency is 5 over 2. Our amplitude, well, is the distance from the middle going up or going down, and that is a distance of 130 minus 123.5. This is going to be 29, 10, so this is 5, 6, 6.5. And our midline is y equals 123.5. Okay, so there you have it. Now, again, I appreciate you watching. This is the end again of these notes. I appreciate you watching. Like always, I hope you have a great day, and goodbye.